Mr. Ryan, alright? Okay. Let's look at this very interesting problem. Come on, listen to me. Let's ready.
Yeah. You
Suppose
don't have
that-
any hairs.
It's a stick man.
It's naked. And you just don't have 3 hairs.
Naked. Okay, I'm just putting on some clothes already.
It
Okay?
tastes
I
smooth.
can do it.
Okay, come on,
I'll
listen.
do it better.
No.
I'll do it even better.
Okay, and
Then you can never say-
okay, draw a figure here. Draw a figure.
Okay. Me.
There's a pencil there.
Okay.
That one is running out. That one is running out already.
I'll do the other half.
Okay. That one is running out, so we can just throw this away, okay? Throw that away. Ah, better. Ah, thank you for that. Yeah. What's that?
Huh?
My legs are not that short. Okay, enough. Okay, good. That's good enough. Okay. Do I have a little big hand? Okay, that's it. Can I have your pen, please?
Why?
Yeah, because this one is good. Okay, so look, Daddy's here. That's Eric or Ryan, doesn't matter. Just 2 people. 2 people. So let's say I'm starting at a position 1, right? And then you are starting at position 2, okay? It's too far, but 2. Let's put 2.
That's a little troll.
2, okay? And obviously this is start. Start equals 1. And it's one line, okay? It's one dimensional. Daddy will go left or right only. There's no other direction. Just left or right. And then Ryan is here, right? Or Eric. Ryan, Eric. Okay?
Just do it Rayik or Aran.
Okay, that. Okay.
Aran sounds cooler.
Yeah, Aran.
Aran.
It's mixed together.
E.
R-A-N.
Okay? That's
Yeah.
it. Aran. Okay.
A-N from Ryan and E-R from Eric.
That's good. Okay, N is here. And then now we also given an integer k equals 3. So the question, listen, the question here. Daddy can only move left and right 1 step. Okay?
It is right that way.
Yeah. Because right, left. Daddy can only move 1 step at a time. I can go right or I can go left. So the question is, how many ways if I want to touch you, that in exactly 3 steps? Okay, I give you an example. So 1, I go to the right 1 step is 2, but that's not enough because you only take 1 step.
That way.
Good job. Okay, so that's 1, 0, right? And then 1, and then 2. How many steps? 1, 2, 3. 3 steps. 1, 2, and 3, 2. This is also okay, right? Also 1, 2, and go back. 1, 2, right? So there are 3 ways. If I want to touch you using 3 steps.
Yeah, but on the first one you already touched.
Good point. Okay,
So-
that's
so
good point.
so
We can cross it, but not touch it. The thing is that.
But it's not like you can fly over. You said so. Since there isn't forward and
Okay.
backwards, so it's 2D. It's like a video game. Dun 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 dun. Meow.
Okay. I did not rephrase it correctly. Okay, so the question is that how many ways that for Daddy to end up in the same position of Iran, using exactly k steps, and suppose Daddy can only move left or right.
What if you can't do it?
Good point. So can you imagine what kind of situation that we can do it for Eric for Daddy can't touch the Iran?
When
Zero.
Aran,
Sorry.
when Aran is like 100.
100. Yes, exactly. Yes. Look, there are 100 meters, and then k is too small. If Iran is 100, and k is 3 steps, the best you can reach is that 1, 2, 3, but it's still lot distance apart, right? What's the condition for Daddy can reach you?
Where k is smaller than
The what? K is smaller than what? What's this?
the
What?
this distance.
Yeah, distance. Where down? N minus star, right? Okay, but N could be on the left side. So we need to do this. What's this? What's this? We talked about this. Absolute value, ABS. Remember? Yeah? When absolute x equals x when x bigger than 0. Equals 0 when x equals 0. Minus x when x is smaller than 0. Okay? So it basically is that distance. Look, x is here. X is minus 5. So minus 5, absolute value is 5. It's basically the distance on the line to 0, right? If it's on the left hand side, for example, this is minus 10. What's the distance? What's the distance if a run is in minus 10?
11.
Yes. Minus 10, minus 1, minus 11, right?
Yeah.
But we are getting the distance, so we do this. Mathematically, we do this. We give it 2 vertical bars, which means that we want to get the absolute value. And for any negative values, the absolute value will be the negate version of it. Okay? Very well done. There's also another situation that we can't reach it in K step. I give you an example. Okay, so 1, 2. How about if I say K equals 2? Can I end it up in Iran using 2 steps? If I'm at 1, Daddy at 1, and you are at 2, Iran at 2. And then I'm saying in 2 steps. Can I?
No,
Why is that?
because it's too small.
Why is it too small? No, I can touch you, but not in 2 steps. I can touch you in 1 step, but not 2 steps. So what's the problem here?
You only can do 2 steps. So if you go to around 1 step, you have another step you need to do. So you either could go back or past around.
Yeah, and what's the problem? How can you describe this kind of situation? I mean, yeah, I understand that you understand this problem, right? Right, Eric, do you understand this? Look, I'm at 1, you are at 2. The distance is, small, right? K equals 2. So I'm asking, can I touch you? Can I end it up in 2 using 2 steps?
No.
Why?
Because
Are you alright?
yeah.
Okay, come on, be careful.
Too heavy.
Yeah. Okay, so
Whee!
what's the problem? What's the
The
problem?
problem is that the chair is fall down.
Yeah, I know. But I'm saying, what's the problem with that?
It's possible.
Yeah, it's impossible, but why?
It's possible, I said.
It's possible, huh?
Look, see?
What did you do? I didn't see any difference. 3, okay. Okay. I know you understand it, but you want to try, give it a go?
Is it like because the difference between is 1
That's right, the difference is 1, okay? And
so for 2 you can
the K equals 2, okay?
so you can you can go to around, but you also like
Jump 1 meter.
So what's that thing? What's that thing? Okay, so I give you another example. How about D equals 1 and K equals 5? Can we do it?
Yeah.
Yes. Okay, how
Is it
about
because if it's an odd number, if K is an odd number, it
D has to be odd number, right?
Yeah.
How about if D equals 2 and K equals 3? Can we do it?
No.
I know.
Right? Okay. How about D equals 4 and K equals 8? Can we do it?
No.
Yeah.
Yeah. Well, let's just look at these without checking the distance. Without checking these, okay? I'm not talking about these, I'm talking about it. But you're right. So if D is the odd number, the K has to be an odd number. If D is an even number, K has to be an even number. Right? Am I right? In order for Daddy to end up in Iran. Right?
Yeah.
Okay, do you get it? Okay, now that's good. So we know these 2 conditions to check. Okay, so now think about it. How do we calculate the number of ways? How do we calculate the number of ways? Come on, I need to give it. How do we calculate the number of ways? I mean, it's hard, right? But think about it. How many choices do I have?
You have You
At one step, I mean at one
At
step. Two, obviously. Okay, that's a good start. Daddy have two steps, left or right. So let's say if I have a function called f star, and then I have an n, and I need to do the k step. This returns the number of ways for Daddy as start to end up in n with k step. Alright? So, but you're saying that Daddy has two ways. So the next one will be f star. I can go to the left, right? Which is star minus 1, right? And then n. And how many steps I need to make? I make one step. How many steps I need to make?
K minus 1.
That's right. And another way to the right. So f star to the right.
Plus 1.
Okay. And n. K minus 1. Right? Look, there are only two ways. So we just need to plus together. Right? With this condition, we need to check. Define. If the ABS star minus n is bigger than k, then return 0, right? There's no way to do it. Alright? I calculate the distance. If d is bigger than k, then we return 0. If k is 0, yeah? So now, if k is 0, so
No,
what
no.
happening?
Then
No, k, the k step. So what
You
should...
can't move.
Yeah, I can move, so what do I need to do?
return 0.
If I have a distance with you, then I return 0. If I'm just stand on your spot, then return 1. Am I right? Because I already ended up in your position. If star equal n, then in this case we return 1. Otherwise we return 0. Am I right? Yeah? If k is 0. If k is 0 means that Daddy can't move. Right? But in this case, if I'm already in your position, then return 1 because that counts as one way. Am I right? I don't need to move. It's still 1 way because I'm already in your position. Otherwise, return 0. Make sense?
So do you mean the person around can be in the same spot as you?
Yeah, this is the corner case. Am I right? Because you're given two star and n. I can be in your spot. And if k is 0 and I don't need to move, that counts as 1 solution. Okay, otherwise return f star minus 1 n k minus 1 plus f star plus 1 n k minus 1. Okay, k minus 1. So look, this is what we talk about, right?
Yeah.
We can move to the left or we can move to the right. And the answer will be the sum of both. And what's missing here?
No cash.
Cache, yes, cache. We need to remember the state, right? If we not remember the state, it will be,
Game over.
Explanation.
the time complexity will be exponential. Why is that? Look,
Game
look.
over.
let's start n, and then every time there are two branches coming off. Going to the left, going to the right, going to the left, going to the right. There will be duplications here. For example, if this star n is calculated here, and then you might need it here again. Then if we don't store this value, what happens? If we spend like 10 minutes calculating this big tree, and then it means that we have to do this again. And lots of these little things add up to the time complexity, which is the exponential. But if we put a cache, it means that
Well, remember
we're remembering any state of
time.
star and k. The end is not actually not moving, right? Look, these three parameters, which one is changing, which one is not? I just said. Star and k. Which one is changing, which one is not?
K.
K and,
Star.
yeah, n is not changing, right? I'm not asking around to move. You just stand there. So this is top-down dynamic programming. Without this cache is, brute force. Simulation, brute force. Because we are just simulating going to the left, going to the right. But with the cache, this magic keywords make it a top-down dynamic programming because we are remembering each state, star times k. The star could be many, right? Could be many. But we are limiting it. We are improving by checking this. If the distance is bigger than k, we just return 0. If the distance between Daddy and around is more than k, it means that there's no way to catch it, right? For Daddy to catch around. There's one thing missing. We talk about the odd and even, right? We need to put it here as well. Which is, look, if D is n1 is equals to k is not equals to k and 1, then return 0. Right? We talk about that. This is very important. If k is an odd number, distance is an even number. Or if k is an even number, d is an odd number, then there's no way to end it up in end exactly using k step. Okay, so this is top-down improvement, but we can do it mathematically. For daddy, you say there are two ways. Daddy turning to the left, turning to the right. Right? So if I'm saying daddy needs to turn left using L step. L to the left. Daddy needs to go to the right using R step. What's the value of L plus R? K. Alright? Because I need to spend K steps. And L step to the left, R step to the right. L plus R equals K. What's the second thing? Look. Here. Star. Here's N. So L to the left, R to the right. R to the right. Right, look. R to the right minus L to the left equals what? R minus L equals what? Look, the distance here. This is distance. I'm here. I go to the right. R step. I go to the left. L step. What's R minus L from this picture? What's R minus L in this picture?
D.
D. Okay. We have this equation. Can we solve it? L plus R equals K. R minus L equals D. Can we solve it? We talk about this in early days.
2 R's.
Yeah, we add it up together. Look. L plus R minus L. Right? This bit equals K plus D. This cancels out. 2 times R equals K plus D. R equals this divided by 2. This is known. This is known. This is known. So R known. Okay, so why is this useful? There are K steps. I need to make K step. And R step to the right. There are K steps, and I need to pick R step to go to the right. What's that? There are K apples. I need to pick R apples to eat. There are 3 apples. I need to pick 2 apples. There are combination, yeah. There are K apples. I need to pick R apples to eat. When I eat an apple, I go to the right.
Yeah.
So the answer is C, K, R, which is K plus D divided by 2. This is the answer. Amazing, right? So we talk about, I don't want to repeat. Last lesson we talked about 3 ways of calculating the combination number. In Python, we have this. From math import, we can import com, which is combination. Com, K plus D divided by 2. Or shift 1, which is also okay. So, one last question. What's the problem and what have you learned? Come on, just give me a 2 sentence to summarize what have we learned today.
So there's 2 guys.
2 guys, yes. Are you sure it's 2 guys, not 2 girls, or 1 boy, 1 girl?
2 humans.
2 humans, okay? Yeah.
And one of them, and the start
Yeah.
Is
trying to get to the end with K moves.
yeah.
Exactly K moves, okay? Okay, so that's the problem. And how do we solve it? How many ways we solve it? And what's the condition that...
2.
Okay, 2 ways of solving it. And what's the condition that the answer should be 0? There's no way, impossible. What kind of scenarios that we just say, okay, don't try to move because it's impossible to?
Hi, Chesley.
When K is an odd number and the D is an even number, or K is an even number and D is an odd number,
Okay.
or where D is bigger than K.
Yeah, bigger than K because it's too far. If K is 3 and D is 100, right? So the best thing I can do is just to move 3 to the right one, which still makes 97 distance, right? So that's one thing, okay? Ryan, what have you learned?
About humans trying to get to each other.
Okay, good. But do you understand this, yeah?
Yeah.
Okay. And also there's another way which is bottom up because from this dynamic programming, right? Star minus 1, we can use the dk, which is the step, and then the distance, right? We can use distance, which is let's say dp kd, representing the number of ways to reach the distance d using k step, and then it's based on dp k minus 1, and then d plus 1 and k minus 1, d minus 1, right?
Yeah.
One to the left, one to the right. We can solve this using the bottom-up dynamic programming, okay? And because dpk is based on dpk minus 1, so it's more like a Pascal triangle, right? But it's a little bit different because it's two numbers above the shoulder, so it'll be something like 2, 3, and then there's a 0, and then right, and then that will be the 5, something like that. So dpk will be the sum of the dpk minus 1, d minus 1, dpk minus 1, k plus 1. Okay, so we're not going to dip into these because to implement this bottom up is non-trivial. Like the combination, the Pascal triangle, remember? The values equals the sum of two numbers above it. And if we implementing using the bottom up approach, it's non-trivial. We can make mistakes when implementing such things because there are lots of details to consider, especially when handling the boundary. It's better we use this cache, right? Cache, top-down dynamic programming. Let the computer handle the recursion and the boundary edge cases. Or we can use this. The most important thing today is this. There are k steps, and we want to pick k plus d divided by 2 step to the right. There are k apples. We want to pick this number of apples to eat. When we eat an apple, we go to the right. Right? Okay, that's it for today. Bye-bye.
Bye.
Bye-bye.